Systems of Equations, Lesson 2, Algebraic. So this lesson is going to focus on solving systems of equations algebraically. Recall that systems of equations can have 0, 1, 2, or an infinite solutions depending on the type of system. You can apply the algebraic methods of substitution and elimination that you use to solve systems of linear equations to solve systems of linear-quadratic or quadratic-quadratic equations. So first of all, let's look at a linear-quadratic. So solve the following system and verify your solution. We're going to use two different methods. The first method that we are going to go over is substitution. To solve by substitution, we need to isolate one of our variables. So I'm going to make this equation number 1, this equation number 2. I'm going to rewrite equation number 1 and try and get y by itself. So subtracting 5x from both sides, I end up with negative y equals negative 5x plus 10. Multiply each term by negative 1, and I end up with y equals positive 5x minus 10. So this is my new equation number 1. I'm then going to substitute this expression in for y into equation number 2. So equation number 2 is x squared plus x minus 2y. Now instead of y, we're putting in 5x minus 10. And then I have that equals 0. Now I just need to solve this. I only have one variable, and so I'm going to solve it. It's a quadratic equation. First step is to distribute this 2 in, and we end up with x squared plus x minus 10x plus 2 times 10 is 20 equals 0. Collecting like terms, x squared minus 9x plus 20 equals 0. I now have a quadratic equation. I'm going to check and see if we can solve it by factoring, and in this case we can. We could also solve it by using the quadratic formula or completing the square. This will factor into x minus 4 and minus 5. The next step is to make each of those equations equal to 0. So x minus 4 equals 0, and x minus 5 equals 0. This will give me solutions of x being equal to positive 4 and x being equal to positive 5. We need to remember, though, that because we're dealing with quadratic functions and two variables, we actually need to find the y value that matches those. So we're finding the y value. We're looking for the point where they cross. Then I need to find y when x is equal to positive 4. Then I'm going to need to find y when x is equal to positive 5. So starting when x is positive 4, I'm going to substitute back into the equation that y equals 5x minus 10. Gives me y equals 5 times 4 minus 10, or y equals 20 minus 10. So y is equal to 10. This is then the point 4 and 10. I can then need to find when my y value when x is equal to 5. So same process, I'm going to substitute into that same equation. So I have 5 times 5 minus 10. So y is equal to 25 minus 10, or y is equal to 15. This is then the point 5 and 15. To verify this equation, I want to substitute both of those solutions in. So first of all, let's verify the point 4 and 10. And because I've been working with equation 1, we're now going to substitute it into equation number 2. So substituting in those values into equation number 2, I end up with 4 squared plus 4 minus 2 times 10 equals 0. 4 squared is 16 plus 4 minus 20 equals 0, which works. I'm also going to verify the point 5 and 15. So substituting into equation number 2 gives me 5 squared plus 5 minus 2 times 15. And I need that to equal 0. 5 squared is 25 plus 5 minus 30 does in fact equal 0. So both solutions work. And my solution set then is 2 points. The first one, 4 and 10. And the second one, 5 and 15. Now I told you we were going to solve this 2 different ways. So that was the first method. The second method, I'll pull up a blank page, is to solve it using elimination. So our equation number 1 was the equation 5x minus y equals 10. And equation number 2 is x squared plus x minus 2y equals 0. To solve by elimination, we need to first of all get the numbers in front of the x's or the y's to be the same. So we are going to multiply equation number 1 by 2. If we do that, we end up with, we're going to do it by negative 2. So I end up with negative 10x plus 2y equals negative 20. Remember that you need to multiply each term. Equation number 2 then, I'm going to rewrite so that my like terms line up. So I don't have a squared term in equation number 1, so I'm going to start with that. Then I have plus x minus 2y equals 0. So you'll see that my y's are one under the other, my x's and my x squareds that I had in both would line up. Now, we need to either add or subtract to make one of our variables disappear. So we're going to try and get rid of our y value. To do that, we would need to add both. So I don't have an x squared term in my equation number 1, so 0 plus x squared is just x squared. Negative 10 plus x is negative 9x. Positive 2y minus 2y is 0. And on the left, negative 20 plus 0 is negative 20. I'm going to bring my negative 20 over onto the left, and I have x squared minus 9x plus 20 equals 0. And I would then continue to solve this as a quadratic equation. You'll notice that this happens to be the same quadratic equation as we ended up with when we were solving by substitution. Okay, now we're going to look at a situational question. It says, Glenn loves to challenge himself with puzzles. He comes across a website that offers online interactive puzzles, but the puzzle maker present the following problem for entry to their site. We're asked to write a system of equations that relates the problems. It says, so you like puzzles. Well, prove your worthiness by solving this conundrum. Determine 2 integers such that the sum of the smaller number and twice the larger number is 46. Also, when the square of the number is decreased by 3 times the larger, the result is 93. In the box below, enter the smaller number followed by the larger number, and you'll gain access to our site. So we need to write a system of equations. So we have 2 numbers, the smaller and the larger. So this s is going to be equal to our small number, and L is going to be equal to our large number. We now need to come up with 2 equations based on the information that we're given. Our Our question says the sum of the smaller number and twice the larger number is 46. So that's going to form equation number 1. So the smaller number is s, and twice the sum of that, so I'm looking for a sum, and twice the larger number. Twice the larger number would be 2L, is 46. So there's equation number 1. Equation number 2 comes from when the square of the smaller number, so square of the smaller number would be s squared, is decreased by, so if I'm decreasing it, I'm subtracting, 3 times the larger number. So 3 times my larger number. The result is 93. So there's equation number 2. Part B is to solve this equation algebraically. So let's move this up. So we have our 2 equations. What we're going to do is to solve it by elimination. To solve it by elimination, I want to get the same number in front of, I'm going to pick my L variable. So that means that for equation number 1, I want to multiply each term by 3. This is going to give me 3s, this is equation number 1, plus 6l equals 46 times 3 is 138. To get 6l from equation number 2, I am going to multiply it by positive 2. And so it will become, I'm going to leave myself a little bit more room here. This is equation 1, equation number 2. Equation number 2, 2 times 2s squared is 2s squared. I don't have an s term, so I'm going to leave that area underneath there blank. And 2 times negative 3l is negative 6l. 93 times 2 is 186. Solving by elimination, in order to get rid of my L variable, I'm going to add both terms. So this is like having a 0 here. 0 plus 2s squared is just 2s squared. 3 plus, again, this is like having 0, is plus 3s. 6l plus a negative 6l disappears. And 138 plus 186 is 324. To solve this quadratic equation, I need to start by bringing my 324 over to the left, and I end up with 2s squared plus 3s minus 324 equals 0. This quadratic equation is factorable. It will factor into 2s plus 27 and s minus 12. To find my solutions, I need to make each bracket equal to 0, so 2s plus 27 can equal 0, or s minus 12 can equal 0. Solving the first one, moving 27 to the other side gives me 2s equals negative 27. Divide both sides by 2, s is equal to negative 13.5. This one is not an integer. And our question said that they had to be integers, so that solution won't work. Solving the second solution, we end up with s being equal to positive 12. So this gives us our smaller number. To find the larger number, we can find that by substituting back into either one of our original equations. So let's substitute into equation number 1. And we end up with 3 times 12 plus 6 times the larger number is 138. 3 times 12 is 36, plus 6l equals 138. Subtract 36 from both sides. 6l equals 102. Divide both sides by 6, and we end up with l being 17. And so our solution is 12 for the smaller number, 17 for our larger number. One more word problem for us. A Canadian cargo plane drops a crate of emergency supplies to aid workers on the ground. The crate drops freely at first before a parachute opens to bring the crate gently to the ground. The crate's height in meters above the ground in seconds after leaving the aircraft is given by the following two equations. The first equation represents the height of the crate during the free fall portion, and equation number 2 is the height when the parachute opens. So part A asks us, how long after the crate leaves the aircraft does the parachute open? So we're looking for a solution to those two equations. I'm going to solve by substitution because I already have one of my variables by themselves. And so I'm going to substitute in for h. So I end up with, instead of h in equation number 2, I end up with negative 4.9 t squared plus 700 equals, remember I'm substituting into here, negative 5 times t plus 650. I'm going to bring everything over onto one side of the equation. So I'm going to move everything to the right, so adding 4.9 t squared and subtracting 700. So add 4.9 t squared and add 700. Sorry, subtract 700. On the left, we'll leave me with 0. On the right, I will have 4.9 t squared minus 5t, and 650 minus 700 is minus 50 equals 0. Oh, I've got 2 equals zeros. There we go. I now have a quadratic equation. Because of the decimals, it's probably not something that's easy to factor, although I could multiply everything by 10 and do it that way. I'm going to choose to solve it by using the quadratic formula. Remember that our quadratic formula is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So substituting in, I'm going to need a little bit more room, so I'll move this down. We end up with x being equal to negative b, which is negative 5, plus or minus the square root of b squared, so negative 5 squared, minus 4 times a, which is 4.9, times c, which is negative 50. All of that is over 2 times a. Simplifying, we end up with 5 plus or minus the square root of 1005 all over 9.8. Because I'm already working with decimals, I can get approximate answers in decimals. So if I do 5 plus root 1005 and 5 minus that, I end up with solutions of 3.7 or negative 2.7. We can't have a negative time, and so this solution we will discard. And so the answer to the question, how long after the crate leaves the aircraft does a parachute open, is approximately 3.7 seconds. Part B asks us, sorry, wanted to move that down. Part B asks us what height above the ground is the crate when the parachute opens. To figure that out, I want to substitute in my time of 3.7 and find my height. So my height is negative 5 times 3.7 plus 650. So h is equal to, solving that gives me 631.5 meters. Part C asks us to verify our solution To verify, we would need to substitute in 3.7 for t and 631.5 into both of our equations.